Hello, my name is Joe, and I'm coming here right now to work through these exam problems for a Calc 3 exam that I've taken. Just going over mistakes and trying to correct myself on what I've done wrong. So, just in this video, we'll tackle 6 different problems and show how they're each solved. Okay, and just hitting the first question, we're hit with both a part A and a part B. The part A is if the vector a dot b is equal to square root 3 and a cross b is equal to the point 1, 2, 2, then find the angle between vector a and vector b. So first things first, what I like to do here is to write out what I do know. So far we know that a dot b is equal to the square root of 3 and a cross b is equal to the point 1, 2, 2. And we're trying to find the angle between the two. So we need 2 equations to really get this problem tackled. It is the magnitude of A dot B is equal to the magnitude of A times the magnitude of B times cosine theta. And we also need that the magnitude of A cross B is equal to the magnitude of A times the magnitude of B sine theta, right? So through manipulation, we realize that our big thing in solving this equation is to get the magnitudes by themselves or to one side by themselves. So in this, we do sort of a separation type of thing where we know that the if we divide by cosine on both sides, we can get that the a dot b divided by cosine theta is equal to the magnitude of a times the magnitude of b. And then we also know that if we divide by sine on the lower function, we have a cross b sine theta is equal to the magnitude of a and the magnitude of b. And once we've done that, to make it easier, we set these 2 problems equal to each other. So all in all, that we have a dot b over cosine theta is equal to a cross b sine theta. And to further simplify this, we multiply by sine theta to get this sine from over there. So we have sine theta divided by cosine theta times the magnitude of a cross b, a dot b, is equal to a cross b. And through further simplifying, we divide by the magnitude of the dot product. So it is sine theta divided by cosine theta is equal to the magnitude of the cross product of a dot b, cross b, divided by the magnitude of the dot product of a dot b. And through some trig functions, we know that sine theta divided by cosine theta is equal to tangent theta. Okay, and having our numbers here, we insert what numbers we have that were given to us. So we know that A cross B is equal to 1, 2, 2. The magnitude of that and the magnitude of the square root of 3 is equal to tangent theta. And finding the magnitude of this, we know that 1 squared plus 2 squared plus 2 squared over the square root is equal to the square root of 1 plus 4 plus 4, which is the square root of 9, which simplifies out to 3. And the magnitude of the square root of 3 is just the square root of 3. So we know that tangent theta is equal to 3 divided by the square root of 3. And we take the inverse tan of this function to find that our angle of 3 divided by the square root of 3 is equal to 60 degrees. So for part A, we know that the angle between the vector A and B is equal to 60 degrees. All right, now for part B, we're supposed to show that the cross product of AB squared is equal to the magnitude of A squared times the magnitude of B squared minus A dot B squared. All right, and to simplify or to figure this out, because we're not using the previous information, I just use a substitution of the rule of both these equations. So I know that A cross B is equal to the magnitude of A times the magnitude of B sine theta, and we know that has to be squared, is equal to the magnitude of A squared, magnitude of B squared, minus the magnitude of A, the magnitude of B, cosine theta, with the whole value squared. And through doing all this, we know that the magnitude of A squared, magnitude of B squared, and then sine squared theta is equal to the magnitude of A squared, magnitude of B squared, minus the magnitude of A squared times B squared times cosine squared theta. All right. And then after that, we would add the magnitude of A squared times the magnitude of B squared times cosine squared theta to both sides. And subsequently, we would take this from this side and move it to that side. So we have the magnitude of A squared, B squared, sine squared theta, plus the magnitude of A squared times magnitude of B squared, cosine squared theta is equal to the magnitude of A squared, the magnitude of B squared. Okay. And then from here, we know that sine squared theta plus cosine squared theta is equal to 1. Correct? So using this rule, this trig function, we know that A squared, the magnitude of A squared times the magnitude of B squared times 1 is equal to the magnitude of A squared, magnitude of B squared, which we have proven is true. All right, and now we are headed to question number 2, where it says, are these points of P, Q, R, and S coplanar? If not, find the volume of the parallel pipe bed with adjusted edges, PQ, PR, and PS. All right. So first we need to find out if the points are coplanar. So the way to find that out is you take the triple scalar product, which is A times A dot B cross C, and the magnitude of the whole thing. So for the points, we can use the magnitude of 0.103 dot 1, -2, and 5 cross 3, 1, and -1. And the magnitude of that. So to take the cross product of these 2 points here, do I, j, and k, 1, -2, and 5 with 3, 1, and -1. So for the function of I, we have -2 times -1 plus 5 times 1 plus j time with the 5 times 3 minus 1 times 1. And for the function of k, we do 1 times 1 minus 3 times -2. So this is a 2, this is a 5, a 15, a -1, a 1, and a -6. So this is where I've done my first mistake, actually, because it's supposed to be -1 times -2 minus 1 times 5. So 2 minus 5 is equal to -3i plus 14j minus, what is that, 6, 7k. So again, I've made another mistake. It's not supposed to be 14, it's supposed to be 16. So this is the cross product of 1, -2, 5, and 3, 1, -1. And after that, we do the dot product of 1, 0, 3 dot -3, 16, -7. So we have -3 plus 0 times whatever plus 21, -21. And it is not 0, so it's not coplanar. So now we have to find the points PR, PQ, and PS. So when I find these points, I like to just put them all in a row to make it easier for myself. And then so it'll be 1, 1, 1. Zero, 0, 0, and a 3, 3, 3. And for Q, we have 1, -2, and 5. And for R, we have a 3, a 1, and a -1. And for S, we have a 1, a 2, and a 3. So PQ is 0, -2, 2. PR is equal to 2, 1, and -4. All right, and PS is equal to 0, 2, 0. All right, and with this, we tend to find the volume of the parallel pipette. We again do the triple product of all three. So for this, we would have 0, -2, 2, dot the value of the cross product of PR and PS, which is 2, 1, -4, cross 0, 2, 0. All right. So just to start off with the cross product, so we can move forward, I, j, and k for each vector, unit vector of 2, 1, -4, and 0, 2, 0. Makes it really easy when we have zeros in it. So for the vector I, we have 1 times 0, minus 2 and -4, plus the j unit vector of -4 times 0 plus, no, it's not plus, I'm sorry. Two times 0. And then for vector k, we have 2 times 2 minus 0 times 1. And through all the simplification, we have the vector 8, 0, 4. And through all that, now we have to take the dot product with the vector 0, 2, -2. Which is equal to 0 times 8 plus 0 times -2 plus 2 times 4, which would equal 8. And we take the magnitude of that, which is the square root of 8 squared, which is equal to 8, is the volume of the parallel pipette. Okay, and then for question 3a, we have convert the surface 4y squared plus z squared minus x minus 16y minus 4z plus 20 is equal to 0. And we have to put that in the standard form and classify the surface of the graph. So my first step whenever I see a formula like this is I like to get the like terms close together. So I change it from 4y squared minus 16y plus z squared minus 4z minus x plus 20 is equal to 0. All right. And then for these formulas here, I have to complete the square of these two to find out what the actual C value of these equations are. So for y, I have -16 over 8 because it's equal to b divided by 2a is equal to -2. And for z, I have -4 over 2 is equal to -2. All right. And then finding these two values allows me to pull out the simple value of 4 for y. So it's 4 times y minus 2 squared plus z minus 2 squared, and have that equal to x. And looking at this, we know that this is an elliptic paraboloid. Sorry for being left-handed. And seeing this, we have to find out where our E is, or where our center of the plane is. So E is equal to C minus B squared over 4A. So our C is 20 minus 16 squared, the negative 16, of 4 times 4. So E is equal to 16. And originally it was 20, so we have a value of 4. So that would be for our center of the plane. It's a combination of 4. All right. So graphing this function, just do a simple graph. Not the best sometimes. With our origin being 0, and knowing this, we know that our paraboloid can not be negative, because whenever you put in a negative values for these functions, it will always end up as positive. So x can never go, it can never go in the negative x direction. Not y, funny. Z and y. So this is our xy plane, and this is our z plane, with correlating to our function here. So it's sort of like a cone. So it's like this here with a circle on it. And that is our elliptic paraboloid. All right. And then for 3b, they want us to find the parametric and symmetric equation of a line passing through 1, 1, 2, and perpendicular to both the ij and the jk. So first things first, just to find the perpendicular plane, I do the cross product, because the cross product is the identical plane of I and j, which is ijk 1, 1, 0 cross 0, 1, 1. So taking the cross product, I know that I is equal to 1 times 1 minus 0 times 1 plus, for j, I have 0 times 0, which is not 1, plus, oh, not plus, minus 1 times 1. Plus k, which is equal to 1 times 1 minus 0 times 1. So for the final outcome of the cross product, we have 1, negative 1, and 1. So knowing that our function is r is equal to v naught plus t times v, and our v naught is equal to 1, 1, 2, we have a function of 1, 1, 2 plus t times 1, -1, and 1. So our R of t is equal to 1, 1, 2 plus t of 1, -1, 1, which is also equivalent to 1 plus t, 1 minus t, and 2 plus t. And taking these subsequent functions and turning it into our symmetric equations, we have that t is equal to x minus 1, which is equal to 1 minus y, which is also equal to z minus 2. So now we have the question number 4, which is find the equation of the plane that passes through 1, -1, and 1 and contains the intersection of the planes x plus y minus z equal to 2 and 2x minus y plus 3z is equal to 1. All right. So we're given the planes of x plus y minus z is equal to 2, and also the plane 2x minus y plus 3z is equal to 1. So setting these equations equal to each other, we have x plus y minus z plus p times 2x minus y plus 3z minus 1 is equal to 0. So the reason I put a p is because I'm not sure what the differential between the two equations are. So that value of p is there to help me find the value so that they can equate to each other. So I have a 1 plus 2p times x plus a 1 minus p times y plus a -1 plus 3p times z minus 2 minus p is equal to 0. So now that we have this equation with a differential of p, we are able to figure out what that p is because we are given the point 1, -1, and 1. So inputting those points, we have a 1 plus 2p times 1 plus 1 minus p times -1 plus -1 plus 3p times 1 minus 2 minus p is equal to 0. And through all the math, we know that 5p is equal to 3 and that p is equal to 3 over 5. So knowing that, we know that our differential between the two is 3 over 5. So inputting the 3 divided by 5 into p, we are able to find a common function between the two. So I inputted the 3 over 5, which is this 1 plus 2 times 3 divided by 5 of x plus 1 minus 3 times y plus -1 plus 3 times 3 divided by 5 times z minus 2 minus 3 over 5 is equal to 0. And through all the math, we know that 11 over 5 times x plus 2 over 5 times y plus 4 over 5z minus 13 over 5 is equal to 0. And that would be a correct answer, but just to further simplify it, we multiply everything by 5, and we have that 11x plus 2y plus 4z is equal to 13. Okay, and just moving along to question number 5, it says find the equation of the normal plane and oscillating plane of r of t if it is equal to cosine t, sine t, and ln of cosine t at the point 1, 0, 0, 1. So finding the normal plane is just a whole bunch of derivatives. And the first is to find the tangent plane. And the tangent plane is equal to r of t divided by the magnitude of r prime of t. And the derivative of r of t is equal to sine of t, negative sine of t, cosine of t, and negative tangent t divided by the magnitude, which is sine squared, cosine squared, and tangent squared. And we know through our trigonometric functions that sine squared t plus cosine squared t is equal to 1. So it equates to the square root of 1 plus tangent squared of t, which is another trigonometric function which is equal to secant squared t. And the square root of secant squared t is just secant. So we know that the tangent vector is equal to negative sine t divided by secant t, cosine t divided by secant t, and negative tangent t divided by secant t. And through another simplification, we know that 1 over secant is the same thing as cosine. So just changing all that, we know that negative sine t, and cosine squared t, and negative sine t is our tangent vector. Now our next step is getting to the normal vector. The normal vector. The normal plane is equal to the derivative of the tangent vector divided by the magnitude of the tangent vector. So the tangent of negative sine t cosine t is equal to the negative 1/2 of cosine 2t. And the derivative of cosine squared t is equal to the negative sine 2t. And the derivative of sine t is equal to negative cosine t. And in doing so, we know that negative 1/2 of cosine t and the negative sine 2t and the negative cosine t, and the magnitude of that is the 1/4 cosine squared 2t and the sine squared 2t and the cosine squared to this cosine squared t is our normal vector plane. And through entering what is our t value of 0, we know that our tangent is 1, 0, 1. And using that, we substitute and we find that the normal plane of 0 is equal to the 1 divided by the square root of 5 of negative 1, 0, negative 2, which is equivalent to negative 1 divided by the square root of 5, 0, and the negative 2 over 5. All right. Ooh. And now next thing is for the equation of a normal plane is equal to our initial point found by our tangent vector times the dot product of our x value and the points that we have of 1, 0, 0. So in doing that, we have 0 times x minus 1, which is 0, and then 1 times y minus 0 is equal to 0, and 0 times 0 minus 0. So all in all, we know that y is equal to 0. So that's our equation of our normal plane. And now finding our oscillating plane, we know that is our normal plane cross our tangent plane, which is the negative 1 over square root of 5 times and 0, and negative 2 of square root of 5 is equal dotted by 0, 1, 0, which is our plane that is distributed by I'm gonna put the cross product, which is now our negative 2 of the square root of 5, 0, and our negative 1 over the square root of 5. Okay, and the final problem for Calc 3 is question number 6. It says, find the curvature of R of t when it is equal to t squared ln t and t of ln of t at point 1001. 100. So we know that our curvature is equal to the magnitude of our R of t cross equal to the magnitude of R prime of t cross R double prime of t divided by the magnitude of R prime squared when t is equal to 1. So first is finding out what our R prime is, which is simply 2t for x, 1 over t for y, and ln of t plus t times 1 over t, which is equal to 1. And the reason we did that is because we did the derivative is because we did the derivative by parts. So first we did the derivative of the first times the second plus the derivative of the second plus times the first. And inputting that our t value is equal to 1, we got our first point is 2, 1, and 1. And for our second derivative, we did 2t the derivative is simply 2, and 1 over t is negative 1 over 2 negative 1 over t squared, and then the derivative of just ln t plus 1 is just the derivative of ln t, which is 1 over t. And inserting the value again of 1, we get the 2, negative 1, and 1. And again, over here, just simply trying to find the r prime of the r prime of t. We just did the 2t squared plus the t to the negative 1 squared plus the ln of t plus 1 squared. And through all that, we find out through that our 4t squared plus t to the negative 2 plus ln of t squared plus ln 2ln plus 1. And we find out when we put in the value of 1, we have r prime of t is equal to 6, square root of 6. So we know that our bottom value is the square root of 6 cubed. Now moving on to our top, we have to do the cross product of r prime of t and r double prime of t, which is our 2, 1, 1 and our 2, negative 1, 1. So for our I, we did 1 times 1 minus 1 times negative 1. And for our j vector, we did 1 times 2 minus 1 minus 2, 1 times 2. And for our k vector, we had our 2 times negative 1 minus our 2 times 1. And through simplifying, we find out that our vector for the cross product is 2, 0, and negative 4. And after we find that, we must find the magnitude of it, because that's what we're going to enter in. So our magnitude of 2 squared plus 4 squared is equal to the square root of 4 plus 16, which is equivalent to the square root of 20. So now that we have our values, we just plug in. So we know that our magnitude of our r prime cross r double prime is equal to the square root of 20. And we know that our r prime and the magnitude of that is equal to the square root of 6. So 20, the square root of 20 divided by 6 times the square root of 6. And then we simplify by pulling out factors, because we know that 20 is a factor of 4 times 5, and the square root of 4 is 2. So we simplify that, pull that out, and we have the square root of 5 divided by 3 times the square root of 6 is our curvature for our RT, that is equal to t squared of ln of t and t times ln of t.